Hi, welcome to part 2 of using implicit differentiation. So I wrote a much tougher equation here. Now I'm careful not to call this a function because of the y squared and y cubed. This will not be a function. So we still want to be able to find its derivative. Remember, the purpose of derivatives, we want to find out how is this function changing over time or something like that. So what we're going to do is we're going to take the derivative. When I take the derivative of this function right here, it's very easy to do. I'm going to, my x is very simple, I'm going to get 2x. Remember, it's a chain rule, it's really times the derivative of the inside, which is just 1. We're just never going to write that. Minus, now the AP loves this, right here, there's a product rule. There's a product rule right there. So when I take that derivative, now I'm going to put this in brackets, it's going to be the first times the derivative of the second. Now the derivative of y squared, drop your power, I get 2y, but don't forget, because of the y here, I'm going to multiply that by the derivative of that y, which is dy dx. Normally what people just think, anytime you take the derivative of anything with a y, just add dy dx. So that's the first part of my product rule, plus the second, not the derivative this time, times the derivative of the first, which is just 1. Bracket. Plus, now I got to take the derivative of this 4y cubed, and that's easy enough to do. Drop your power, I get 12y squared, but we're not done. Remember, it is a chain rule. I got to multiply by the derivative of that y, which is dy dx. Now again, most people just think, oh, it's a y, I just tack onto a dy dx, and they're okay with that. Don't do all that beautiful work and put a 10 there. The derivative of 10 is 0. Be careful. I'm going to distribute. Now I'm going to clean this up a little bit. Minus 2xy dy dx minus y squared plus 12y squared dy dx equals 0. And now again, anything that has a dy dx, even the signs, will get to stay. They're pretty cool. They get to join the party. Everybody else has got to go. So I'm going to write this negative 2xy dy dx plus 12y squared dy dx, and that's going to equal negative 2x plus y. So factor out my dy dx, and we get, times negative 2xy plus 12y squared equal to negative 2x plus y, and I just divide. Dy dx equals negative 2x plus y divided by negative 2xy plus 12y squared. My light went off. Let me see if I can get it on. Hello. Okay, there we go. And there is our derivative right there. Very easy to do. So if you go back, try some. So let's try one with some trig stuff. Let's get triggy with it, okay? Let's try this one. Sine x cosine y equals root 3 over, 7. I'm just going to make that up. I have no idea if that's even a number there. But I want to take this derivative. Now again, AP loves this product rule. And this has a y on it, so we know because of the y, we're going to use implicit differentiation here. So the product rule says just find the first sine x times the derivative of the second, be careful, which is negative sine y. But because of the y, I'm going to add a dy dx there again. Very simple to do. Plus the second cosine y times the derivative of the first, which becomes cosine of x. Now again, this is a derivative. I'm really going to multiply by the derivative of the inside of x, which is just 1, but we don't ever have to write that. And that's just equal to 0. And this one's pretty easy to solve for. Dy dx equals, bring these over. We're going to get, what's that, negative cosine y cosine x. Divide that by negative sine y sine x. Negatives cancel. You can leave it like that, that's cool, but just remember that's just the cotangent of y times the cotangent of x. Code x, I don't know. And there's our derivative. Now a very popular one on the AP test is this one. And this is a tough one right here. Let's do a couple more here. All right, number 3. It'll focus there, hopefully. 3 Just hit the focus. There we go. Let's try this. There we go. Another example. Y equals the cosine of xy. Love this one. A lot of people tend to miss it. Very easy to do. Now we have a chain rule here. Look at that. We actually have a real chain rule, a real life chain rule. And inside that chain rule, we have a product rule. And now I talked about like bigger picture. Chain rule is much bigger than the product rule, so we're going to do chain rule first. But when I take the derivative, we know this. The derivative of y is dy dx. And that's going to equal, well, the derivative of cosine is negative sine of xy times the derivative of the inside. Be careful, the inside is product rule. It's going to be, now I'm going to put this in brackets because it's product rule, right? The first times the derivative of the second, which is just dy dx, plus the second, which is y, times the derivative of the first, which is 1. Now, this is tough because I have to, now that's my derivative. Calculus done. I got to find dy dx. So what am I going to do? I'm going to distribute. Dy dx equals negative sine of xy times x dy dx minus sine of xy times y. Anything with a dy and a dx has to be together. So I'm going to bring this dy dx over by adding it. So plus the sine of xy dy dx equal to negative sine xy times y. Factor out your dy dx. Be very careful. This is 1 plus the sine of xy equal to negative the sine of xy times y. Whoops. I forgot my x over here. Some of you guys probably already figured that out. Put my x there, and I'll put my x out here in the front so I don't confuse it as like x squared. So there we go. So my derivative then will be negative sine of xy y over 1 plus x. See, I remember I forgot my x from earlier. Sine of xy. And there is our derivative. That's a great one to have. I would put that one on a quiz or a test because that's just awesome. Okay, so we've taken a look at a few of these. Okay, so let's see here. What can we use these? Well, we can use these to find derivatives at like a point. So let's take a look at kind of another one here. And then like I said, then we'll go to part 3, which is the second derivative. So let's take a look here. Let's say here we have an example. Let's say, oh no, focus. Let me see if I can get that focused here real quick. Sorry about that. Technical issues. It just won't remember. So let's say we have x, y equals 6. And I want to find the slope at negative 6, negative 1. I can do this one of two ways. One, I can solve for y and take the derivative. But that's just a little bit tougher to do. So sometimes what I'll just use my implicit differentiation, which says take the first times the derivative of the second. See, product rule plus the second times the derivative of the first equals 0. So what's dy dx going to equal? Negative y over x. So therefore, to get my slope, I just plug it in. Negative of a negative 1 over negative 6, so I get 1/6. Heck, if I wanted to, I can now even write a tangent line. Y plus 1 equals 1/6, x plus 6. Implicit differentiation we use all the time. So, very easy to do. Okay, so if you go to part 2, we're going to take a look at how to find the second derivative, and that's a lot longer to do. Okay, bye-bye.